So this talk is going to be about microservices and moving from monolith to microservices. We'll get into a little bit of that in a second. But before we really get started, how many of you guys are currently dealing with a monolithic pattern right now? All right, good. Most of the audience. How many of you have started to actually work with microservices in any way? All right, maybe half. And then how many of you just decided to stick on this side of the building and didn't really want to walk the whole way over here? Okay, there one guy. Right. So thank you for walking all the way around to get here today. So my name is Christopher Grant, Senior Architect at Home Depot. You can find me online at cgrant. So this is a story about what we've been doing at the Home Depot. I've kind of been in the industry for about 20 years, and ironically, the Home Depot actually started their website around the same time I started my career. Their website was a little bit cleaner than mine, though. I had the tiled background, and I think I actually used the blink tag a couple times. So don't judge me for that. But this is what the site looked like back in 1996. So it's really simple, really easy, and this was par for the course back then. And really, this is kind of the story for a lot of the applications these days. You start out small, they're lean, you're ready to take on the world. You add a couple features here and there, and then one day you've got this big monolith. And that happens with a lot of applications, not just 20-year-old applications. And so, come 2011, we ended up in that kind of the same boat, right? We had this 2 gig deploy. We had 3-month-long release cycles, 2 to 4 hour deploy outages, and then we had infrastructure drift and pets. With our servers. And we really didn't have much from a CI standpoint. Not a lot of tests, not a lot of automation. So really this wasn't going to work for us. There was a lot of challenges that we had, a lot of things that we wanted to do in the future, and this was going to slow us down. So what did we do about it? How do we start tackling this? So the first thing was really we wanted to increase the rate of change. We wanted to increase the number of developers. We had a lot of plans, like I mentioned, but we had to maintain the existing $1 billion in sales that we were already generating. So one of the first things that we decided to tackle is to take on this idea of agile development. I know today this is a pretty much common thing, but back then this was we were doing waterfall, we were doing those 3-month-long release cycles. We had lengthy testing cycles. So this was important for us to switch over. So we were decomposing the teams and working on that. So once we decided that we wanted to decompose the teams, the next thing was really to take a look at, well, how are we going to start to decompose the site? Right? How do you take these teams and have them work on the site? We have a monolithic site. So where do you start on this? Well, we stepped back, we looked at our system, and we said, hey, we got this browse thing, we've got this commerce thing. What are we supposed to do? So we decided we were actually going to start with the browse side. And then we took a look at the browse side, and we kind of broke that down a little bit further. We said, well, we've got this like store finder thing, we've got a product kind of page, we've got some search. So we broke those down and started to work on some of those. And we piloted a couple of those and then moved on and worked on a couple other ones. So once we decided that we wanted to start with, in this case, we started with Store Finder was our first one. We said, well, how do we automate this, right? How do we add some testing to it? How do we make sure that this rapid release cycle that we're doing is really going to work? So we took on continuous integration. We added Jenkins and Sonar and Git and a bunch of these other tools that today are pretty commonplace. So we had to have our automation in place. So we decided now that we have the whole stack ready to go, we wanted to kind of look at the technology a little bit. So we decided to embrace APIs. Again, this wasn't something that the company had really worked on. So this was new, and the point with the APIs for us is that we wanted to really architect for change. There were some things coming that we knew we were going to have to adjust for. I mean, there was a bunch of other things that ended up happening that we didn't even know about. So this ended up being really, really helpful for us. But here we are, we've got this new process, we've got this new technology, we're ready to go. And our operations team is like, wait a minute, what the heck are you going to do to our site? We're making money here, and you guys want to come in and change this. So how do we mitigate some of this risk? So we added in feature throttles. So these can be really complicated, or these can be really simple. We started out with really simple patterns for this, and we'll talk a little bit more about that in a little bit. But the key here was really, we didn't want to just throw this into production. We wanted to implement these things safely. So what were some of the key takeaways that we learned through this process? Well, really it was that you need to start with a vision. And it's not just starting with a vision, it's understanding what the objectives are for you and your company. There's a lot of things that are out in the market these days, and if you don't understand what your core objectives are, it's going to be a challenge. Are you trying to go for performance? Are you trying to implement some unique streaming technology? Are you trying to go for scale? Are you trying to go for speed of delivery? What are the key things that matter for you and your organization? And then choose what matters from the industry, and make sure that what you're choosing actually matches up with your objectives. And then finally, implement these things in stages. So this is all part of a vision. You want to set out the plan, but you can't necessarily tackle everything all at one time. And for a lot of people, big changes are hard for them to understand. So take your changes and break them up into manageable milestones that people can actually conceptualize and move with. So we started to move on to culture. So the agile side of things, as I mentioned, was new. And with every change, there's going to be some cultural changes. This happens to be a culture model that I really like and identify with, and it's a little hard to read. And I put some notes on the bottom here. You can go look this up later. It's called the Schneider culture model. But any of these culture models are great. What they do in this particular one is it talks about, hey, you've got this collaboration and control and culture, or cultivation and competence, these different areas, and it talks about at the top is more reality oriented and to the right more company oriented. And in this particular case, what the Schneider model is talking about is that if you're in one of these, you can't just jump over from, say, control to cultivation. You actually have to go around the side. And so if you're trying to make a culture change with your organization, try to understand where you are today, where you need to go, and then some of those paths to get there. And so this is just one of those tools that you might use to help you get there. So again, with our move to Agile, we wanted to implement some new changes. And so I had been calling this iterative architecture. And our operations team kind of saw it a different way. They called this changing the wheels on the tire while flying down the highway, right? So we had this billion-dollar site, and we're trying to do all these changes. But really, this is what's being termed evolutionary architecture today. And the main thing about that is that we actually had a plan, and there was a direction that we wanted to get to. So the key here is that we want to architect for change. You need to prepare for future changes. You need to look at what's coming ahead. Make sure that in your systems that you're going to be able to adopt for those. So change is going to happen whether you want to or not. You can either make change happen or it can happen to you. And we want to be the ones that are making the change happen. The next point here is really delaying until that last responsible moment. So given that change is going to happen, let's not set our designs in place today saying, hey, we have to use this technology if we're not planning on using it for 3 months. Right, so make those decisions at the last possible minute. You're going to get new information, some new technology is going to come up, something's going to change in the requirements. So wait as long as you can. I'm a procrastinator, so this one's easy for me. So wait as long as you can to make that decision. And when change does happen, there's going to be rework, and so you should expect that there was going to be rework. Our goal, though, is to minimize what's going to be done. So, in the case of the APIs, I can actually put a hard-coded interface on there, or I can abstract that out. If I wanted to, I'm kind of going off on a rant here, but putting in some of that hard coding at first might seem well, but really, it's okay if you're going to minimize that and have to refactor it later on. And then, so moving past the Agile stuff is back onto the breaking the system down. So here's a book. You guys probably have already seen this by now, but domain-driven design. So domain-driven development is a big thing. And this ended up being one of the positive things for us when we looked at our stack. And on the right is kind of an example of the home page or the product page, and how we maybe kind of broke that up in some of the modules that we were thinking about at the time. And so, take a look at your stuff and take on domain-driven design. The key for us on this one, though, was really to understand what the business products are, Take a look at your organization, see what functions they're doing. What are the different domains in the organization? Do you have a sales organization? Do you have an organization more about customer? Understand the company domain and products, but also identify the people structures. So Conway's Law is a real thing. Take a look at where your teams currently are sitting with the microservices. Do you have people kind of working together on certain modules? Maybe that should be a component that you carve off. One of the other pieces is around the data model. So the databases tend to evolve over time, and they get a lot of stuff in there. But the way that we pull the data out ends up identifying some of those components as well. So look at where the data is getting pulled out of the systems, how are they getting consumed, and those might be some of the pieces that you can use and decompose. And then finally on this slide is look for those hard things. So we all have these systems, and there's things in the systems that we don't want to touch. There's scary things and things that hey, don't go there, it's going to break. Those things might be things that you can carve off and componentize as well. So those are just some of the ways that you can look at your system and start to break down your monolith into smaller pieces. So one of the things that I found while we were going through this, which I hadn't actually come across before, the 8 fallacies of distributed computing. So this is a little bit older. But when we were switching, this is so true, and had we known some of these things and thought about them, there would have been a couple things we did differently, right? Network is always reliable, latency is 0. So a good example, we separated out our APIs, and we had extra latency in our calls, so we added in caching. Some of these things that take a look at these and make sure you're accounting for them in your suite. So finally on this is the implement safely. So there's multiple ways to do this. Really the biggest thing is automate early and often. Make sure that you have repeatable patterns. Make sure you have repeatable process. One of the interesting things is in place versus greenfield. So as engineers, we really like to start something new, and all the old stuff is crap, and we need to create it from my stuff is always better than somebody else's. But for a safety standpoint, it's actually makes sense to go into your system and say, hey, how can I refactor this to be a little bit better? Maybe I can do something with this. So the one thing we actually did here, I mentioned we started with APIs early on. We weren't really accustomed to how were we going to deal with the APIs at the time. So we actually created an API in the existing stack that we had, and we made calls from other parts of the system out and back into the same exact system, just so that we could figure out what is the operation going to look like, what are the calls going to look like, how are we going to do this. It's still a monolith, but we started to treat it like it was distributed systems just so we could understand how to deal with these things. So, and I mentioned this earlier, feature switches and traffic throttles. So there's many different ways you can do this. So we started out with simple if statements in our code. We said, hey, if this, then that, so it can be really simple. We moved to property files. We added in a database later on. And then eventually we got into infrastructure-related changes. So we have a beta servers and whole suites of tools to go there. So the point here is really that you can do feature switching and traffic throttles at a really simple level. And then as you start to get acclimated with that, you can build in complexity and make them a lot more elaborate. But definitely jump in and use some of these techniques. They're going to help implement safely over time. This one I think is kind of funny, is encourage separation and independence. So early on in my career, I went to some leadership training session, and they're like, hey, you need to build bridges, not wall. Let's all, get together, and this is awesome. And the funny thing is, when you're dealing with monolithic teams and structures, it's kind of the opposite. We actually want to break those things down. We actually want to build some walls and encourage teams and systems to be a little bit more independent. So one of the things that we were talking about is, what if that API that we're building, and so let's take an example of a product API and a product page. What if those weren't part of the same organization? What if that product API was part of a third-party company? How would you code your web page to call that? You know, you're going to put a little extra trust around it. You're going to work on that contract a little bit more. You can't necessarily go to the developer all the time and say, hey, what's going on? When's your next release? All the rest of that. So, you know, try to encourage some of that separation and independence. So how did we do? So this was our first run at breaking down our monolith. So we did pretty good. So back in 2011, we were at one major app. In 2015, we had moved to 30. We increased our sales to 5 billion, and we increased our frequency deployments to weekly, and are working with about 300 developers. So that was pretty good. But we're not done yet. So last year, we brought in a new project to take the commerce side. So that was all on the browse side. So we decided we wanted to attack our commerce side. And so we decided we're going to move commerce to the cloud. We're going to continue to break it down to microservices. And we're going to take all of the stuff that we had just finished doing, we're going to move that to the cloud as well and update its technology to be more modern and more microservice related. So now we get into more specific microservice-based conversations, and everybody's talking about microservices these days, right? It's more maintainable, easier to deploy, you know, isolated concerns, and really it's not for just the Netflix and Spotify's anymore, right? So we can all start to adopt these things. A lot of different technologies, a lot of different ways to do this. So how are we approaching it at the Home Depot? So I was thinking through this, trying to figure out how to present it with you guys, and there's a reference that I think is worthwhile taking a look at. Chris Richardson put together this great microservices pattern website, and there's a lot of good resources in it. So I thought I'd actually use that as a way to talk through some of the aspects and some of the things we did. So definitely go check this out. It's a great way to even have the conversations within your organization on these things. So the first thing he talks about are some of the core patterns, and clearly, you know, it's microservice versus monolith, right? So we chose the microservice route. That's really what we were shooting for. But we started to say, hey, well, what are the questions? You know, what are some of the things that we actually need to answer? And these are some of the common things that come up early on. Well, how big are they? And how many should we have? So for us, it was really, you know, what is the context of this, right? So is it really small? Are we looking for something super tiny? But you need to remember that it's all about the context. We're coming from a monolith. So coming from a monolith, it's all about scale. So anybody know who this guy is? Yeah, so this is Melvin Conway. Awesome. You got to bring up Conway's Law in these conversations, right? So Conway's Law, you know, talks about, you know, systems match their organization. And so we took that as a marker. And then we've got to this guy. You guys got to know this one? Somebody? Bezos. Yes, there we go. So he's got another little quote. You guys probably heard of this one, right? So 2 pizza team, right? So these things kind of tended to work together. And we ended up with a 1 microservice per 2 pizza team conversation. So this ends up actually being kind of a decent rule of thumb for us, you know, good sizing thing. Some of the other ones that you might hear out there are 1 per developer, 1 microservice per developer, and you'll hear that in a couple of organizations. Another one you'll hear is 1 microservice per 100 lines of code. I did a little survey, and the 1 per developer is probably the closest, and then this one is the one that's actually getting used a lot in the industry. So those are kind of the 3 different ones that I was able to kind of find that were out there. And the one thing about the kind of the side note about the 1 per developer, the thing that I've noticed in our organization is as some of the microservices get matured and they don't require a lot of support and maintenance, the people that were doing that move on to other things. And so if you actually look at the total number across the organization, it balances out. It doesn't necessarily mean that that's 1 service per person being actively maintained. Just a side note. So we took this sizing rule here, and we coupled it with the domain services that we mentioned before. So we started to kind of put the domain services into sizes that would fit individual teams. So that was kind of the guideline for how we approached some of the microservice conversations. So the other thing we talked about was we had this browse stuff. We had just finished breaking it down and making it into smaller chunks. I don't know if you wanted to call it microservices yet or not, but we're moving things to the cloud. And previously we had this thing called a grid, a Tomcat grid. And it was kind of cloud-like thing. It helped us do some initial breakdown. It was great. But we ended up putting a couple things in place that maybe we wouldn't have done if it was a true cloud. So we decided we need to really figure out how to do this thing. And the cloud native apps was a big topic, 12-factor. I'm sure you guys have heard this by now, but definitely go through and take a look at these things. We went through these line by line and we said, how are we going to manage our code base? Well, we already had that under control, and dependencies. And we went through each of these things. We actually put a list together on how are we going to accommodate these for our stack. And we gave our teams a recommendation on how to track this and use these in their reference applications. So back to Chris Richardson's list. So that was really about microservices. The next one was about communication. So this is really where I think a lot of people start to say, hey, this is what microservices is about, right? It's about the communication patterns. It's about the size. So Chris Richardson talks about these three major things. He's got API gateways, discovery, and registration. So API gateways, I think we've kind of been through that. REST service has been around for a while. They give you token management, and you can do throttling, traffic throttling, metering, things like that. It also provides aggregation technology. So we had some services. We actually provided an API gateway years ago, and so it's actually coming in handy again now. From a discovery side, there's two, which is server side, and we're pretty acquainted with this. And this is typically your standard load balancer pattern. And then more recently, we've got the client side, and you'll see a lot of tools like Hystrix and Feign and a lot of these other things that are out there that allow the developers to actually go and query and manage some of that on their own. I'm going to skip Ambassador just for a second because I added that one in. And then the registration is, as an application, I can register with that central repository myself, or I can have another tool do that for me. And so third party is something you'll see a lot with Docker, and then self is if the application wants to manage that. So we've got this ambassador pattern that I added in here. That's not actually part of Chris Richardson's list. I pulled that off the net. I found that somewhere. And really, it's just a proxy pattern. And we ended up actually using all of these things. And I'll talk about the ambassador in a second. We ended up using all of these. I know that's probably not a good answer to which should I use, but we ended up using all of them. And there's a reason for this. And so really, what we're trying to shift our culture as well as our technology stack. And we don't want to come in and necessarily mandate that each team has to do something. What we did do is we brought in the tools so that the teams can use what they want to use when they want to use it. So the reason for the ambassador pattern is that we brought over this browse application, multiple stacks in there, and we wanted to give them kind of a lift and shift ability and the ability to take on some of these microservice-oriented client-side things when they had time within their application. So the product teams need to keep going, and we didn't want to necessarily stop them. So basically, you've got the server registers itself. In this case, it's third-party registration. The registry updates all the load balancer configurations, which happen to be on the actual node. And then the client app calls a local proxy, and then the proxy calls out to wherever it has to go. So we're kind of mimicking the client-side discovery, but we're doing it in a way that the applications don't actually have to do any code changes if they don't want to. They just have to change their endpoint from named endpoint to localhost, and so we can still manage that way. So as the teams start to change, they can switch over and start to do some of the newer client-side load balancing. So now we switch to the deployment patterns. So there's a bunch of different ways to do this. The single service per host is actually I updated my slides about 20 minutes before this and they didn't. Anyways, single service per host, and that basically is the traditional model that you have. The multiple servers per host is actually what we ended up doing with our Tomcat grid, as I mentioned. We have a bunch of servers, and then we put a bunch of systems on there with different ports. The single service per VM is kind of the older new stuff, right? So now we're on to single per container, right? But maybe last year it was the single per VM, and actually that's what we started to do is really focus on a single service per VM. And why didn't we go to the services per container model? Well, again, this goes back to what I was talking about before about what really mattered to us. Well, what mattered to us wasn't really the density of the system, but it was really more about the immutability of the stack. We didn't want to have these pets, right? So, well, I have to have a picture of a cat in here, right? It's obligatory. So you know, you guys already know the story, but I have to get my cat jokes out there. So you have pets, right? And all the pets tend to be a little bit different, right? And that was the case with our system. And when they get sick, you like to take care of them. But what really mattered for us is we really wanted to get to that cattle, right? So I like cows apparently, but so the key there for us was shifting to the immutable architecture. And that really meant that our assets need to be rebuilt and redeployed, but we really didn't want to modify them. And I know, you know, some of this is kind of repetitive. We had already gone through this multiple sessions, but the issue is about the SSH is a conversation point that keeps coming up. Well, I need to SSH into my box, right? And so we actually had a conversation early on. Well, maybe we should just turn off SSH, right? Everybody freaked out. I gotta get it. So we kind of switched that around. We said, all right, well, you can go in and take a look at them, but we really don't want anybody changing anything. So it's going to be for diagnostic usages. And so we actually will respawn our servers pretty regularly. And so we use base images. So there's a couple patterns here, and I'll talk about this in a second, but we use base images in which it helps speed the deployment and manage some of the maintainability that we need to do from a system standpoint. But then we also use immutable application assets coupled with that base stack. So what does that look like? So here's a full instance. Now there's 3 different ways that we can do this, right? You can take the OS, which most of the cloud providers offer, and then do everything you want on top of that. You can go to the other extreme and create an instance image, which takes all of these layers and bakes them into one image. And the amount of volatility that we had with our developers and our newness to the cloud, we really didn't want to be managing all of those images and dealing with the cleanup and tracking of the images. So what we decided to do is kind of split the 2 of those. We created this foundation image, which included, you know, some of our core things, the agents, proxy I mentioned, and some of the core runtime components. And then we separated that out, and we used the application assets that we were already generating, the patterns we were comfortable with, and we combined them together. And we did that in a simple configuration script. So how did we do this at a larger scale? So we actually created some in-house tools with some of the tools that were provided by our vendors. And we wrapped it together. A colleague of mine named them Hammer and Nail, so I can't take credit for that, but definitely some core things. So on the left here, what you'll see is we take the base configuration that we were talking about before, and all of that's stored in Git. And this was also a great thing for us. Everything we do now is stored in Git, all the configurations, all the disk image, everything. And then when there's change that, the nail process actually goes and creates the cloud disk image for us. And that just sits out there waiting for us to use it. And then the dev teams go through and they got their Java source and the same CI process we're used to. They create their jar assets that's put out in Nexus Artifactory. And then we've got also, which was new to us and was a great conversation point with our security team, and they loved it, was that our cloud configurations about the firewall, the network, all that is also in Git and stored as cloud config in Git. And so we use this Hammer tool that we created to take all of these things and actually apply them in the cloud. So it actually builds our cloud, builds our instances in the cloud. So in this case, it actually takes the base image we talked about, it takes the jar, puts them together and creates this app instance. So it's a pretty similar process to, I guess, what Netflix is doing. They create the full, they create the full image. We're kind of taking that back and we kind of create one step back. So the last piece on here is the data management. So this is an interesting one. So we had gone through and there's some stuff about one database per service. And if you read this, it makes sense until you actually start to do it. So we created services for what we thought were our major domains. And we got into this, and one of the things we realized is we were getting back into this distributed monolith pattern. And so this ended up being one of the key points that we're still trying to deal with, and I think it's a bigger conversation. But basically, we've got a core service that everybody needs to have access to. There's data in that core service that everybody needs to get to use in their service. So how does that end up being microservice then? How did you break down all the release? How is that independent? Well, it's not. And the challenge is, how do you take that data and get it out to every other place? So the one database per service, all of these microservices have their own database, which is great, but we're still coupled to that one core data set. So we are definitely going with the one database per service pattern. But I wanted to show you a little bit more about the decoupling strategies that are available. And we haven't necessarily adopted these yet, but these are definitely some patterns that you can take a look at. So the shared database model is something that we're all pretty familiar with. That's the traditional model. And then you have problems with, hey, what happens if I change my schema? What happens if I do, want different data in there? The shared domain is actually what we're facing right now. And I think it's going to be a common thing for people as they move forward into microservices. And that's the case where, hey, I've got this domain element. In this case, maybe it's our catalog app, maybe it's a customer data, whatever that is. But I've got these other services that need to attach to that. Well, how do they attach to that? Every time I change that domain service, I have to go and regression test all the other ones as well. So I really don't get that dependence. I still have to have that coupling between teams. So then there's the decentralized data. And I think this is really where the point of decoupling and one database per service goes. So in this case, maybe you post all of your changes to a queue, and then each team has a copy of that data. So you solved one problem here, and that the teams aren't necessarily coupled, but then you introduced other problems. Now you have to deal with data duplication, making sure that things are updated across the stack. So there's some give and take on these things, but there's some different strategies here that you probably take a look at. The one other thing on this, though, with the decentralized data, with the queue, if you look at the next one on here, it's the event-driven architecture. So there's a lot of conversations these days about reactive architecture, event-driven patterns. Really, that goes more towards this, hey, how do I use a queue? How do I use events? How do I get the data out? How do I publish whatever's interesting and let people consume it whenever they want? So the progression here, I think, is going to go more towards the data duplication as time goes on. So I've got one last slide here, and this I was thinking about. I'm like, should I close with mine or somebody else's? But I really like this thing by Daniel Bryant. He's a guy in the UK, and he's got some great articles out. Definitely take a look at this. He's got this thing about 7 deadly sins of microservices, and we didn't hit all of these, but some of these actually, were pretty relevant to us. So lust is a great one, and he talks about, hey, you don't necessarily need to use all the latest and greatest tech. And there was another conversation about use boring technology. These are true things. If you bring in all the brand new stuff, that's going to be a problem. Gluttony is really, using all the latest fads and all the different protocols. We're kind of sticking with what we have. Greed talks about, hey, it's actually more complicated than you think. There's process, there's people, there's a lot of these different things. And sloth, that was what we were just talking about, right? There's this distributed monolith. Yeah, so I broke down the technology, but I didn't actually change the organization. I still have teams that need to work together that are coupled, and so we didn't change our process with that. And then a couple of these other things, the shared single domain fallacy, NV, that's the one I just talked about, right? So yeah, we did decoupling, but I've still got that one domain model that everybody needs to have access to. So really, there's a lot to look at. There's a lot of options. These are just some of the things that we did, and I hope some of that was useful to you. And that's pretty much it for today.